So on PC1, let's find the app. So we can delete this ARP table by using this command. Yeah, no entry found. Okay. So in our simulation, we can reset the simulation to start from scratch. So let's go back to PC1 and try to ping PC2. Let's take it here. So we notice that this packet is the first packet that's sent from PC1 going to PC2. And when I catch this packet, we notice it's an ARP packet sending a broadcast address from source IP of PC1, destination IP is PC2. So this is the source IP and this is the destination IP, and this MAC address right here, it's the MAC address of PC1. We can verify that by going to PC1. Type ipconfig or you see this physical address. Physical address B023 is the same B023. So the first packet that's sent out is an ARP packet to get the MAC address of PC2. As you can see, this is layer 1, layer 2. So the first packet we just limiting ourselves on layer 2. We use port gigabit 1/0/1 to send that packet out, and on layer 2 we are doing ARP inspection, checking the MAC address. So we can go into inbound PDU details here to see that the source MAC address is the MAC address of PC1. The source IP is the IP address of PC1, and the target, which is the destination IP, is the IP address of PC2. Now we don't have the target MAC yet at this level. At this level, we don't have the target IP, target MAC address. That is what layer 2 is meant to do. So we are trying to figure out what is the MAC address, the physical address of PC2. So this is what we're doing here at layer 2, at this first packet stage. So the target MAC address is 00. We've not yet found it. The destination MAC address is this FFF, which means broadcast. So it broadcasted the packet so that it can fetch the MAC address of this IP. So now the packet has traveled and it has reached PC2. We notice that it's still the same. Now let's go into the reply of. Let's identify what the reply gives us. So here is from PC2 back into the network. So this is the details of that packet. Now we've gotten this MAC address that he has found. This is the destination MAC address. Right now, this is the destination MAC address, which is the MAC address of PC1. The source MAC address right now, this is it. It has changed. This is the MAC address of PC2. This MAC address is the one of PC2. We can verify that by simply going here, going to PC2, type in ipconfig/all. Notice this 4693. Yeah. So we've gotten the source MAC address of PC2, which was unknown when we sent the first packet, the first ARP packet. So that's it. We've gotten the MAC address of PC2. And now if we continue the simulation, you see the packet is going back to PC1. And now if we want to check, now at this level, this PC knows the source MAC address of this PC. Now it can ping without any timeout. So you see, let's check, make sure. So this is the source MAC address of PC2, destination MAC address of PC1. You see, target is PC1, source target IP, target MAC address is that of PC1. Now the PC can ping without any problem. So let's check on the ping packet. From this packet, we can see that these are two different MAC addresses. This is the MAC address of PC1, and this is the MAC address of PC2. So to confirm, let's just check. This is no longer an ARP packet, but it is an ICMP packet, which is a ping packet. The source here being the source MAC address being the MAC address of PC1. The destination MAC address here is that of PC2. Source IP PC1, destination IP PC2. So this ping is going to succeed. So now this is a ping packet. Now let's continue. Let's make it go to that, and the ping passes through the switches in the network. Now if you go back to real time, this ping will succeed. See, the ping is successful. Now let's go into our switch. Go to enable show MAC address table. So from this, we see that switch 1 has learned that the MAC address of PC1 is this, and it's coming from port gigabit 1/0/1, which is this port. So this switch has learned using ARP that this is the MAC address of PC1 coming from this interface, and that of PC2, this is the MAC address of PC2 coming from this interface. So the MAC address of PC2 is coming from here, and this is it right here. Now we can configure on the PC to change their MAC addresses so that it is very that is easy to understand and to visualize. So let's do that. Let's go to PC. So on this MAC address, let's come to interface. So global interface, let's see. Yeah, let's change this to make it easy to visualize. One. So let's go back to our switch. You can type in show MAC address. Show MAC address table. You see that the new MAC address is this, and it's from this interface. So that's the MAC address of PC1 as we just changed. We can do the same for PC2. Let's change its MAC address. Config. Let's change that. Show MAC address. Now you see the MAC address has changed, and it indicates that it's from gigabit 1/02. So this is where the MAC address of PC2 is coming from. We can also confirm that this MAC address is correct on the PC, at the PC level. You can just come in here, command prompt, IP config /all. You see the MAC address has changed. Do the same for PC1. IP config /all. Same. MAC address of PC1 has changed as well. So if you go on switch 2 and do a show show MAC address table, you notice that it has not learned the MAC address yet, so we're going to ping 192.168.1.1. So now let's go back and do show MAC address table again. Here you go. Now it has learned the MAC addresses of PC1 and PC2.